Good afternoon to all. I, Sunil Kumar Ojha, Assistant Professor in Mechanical Engineering Department, here welcome you to all for this workshop on prototype process design and development. On the behalf of our institution, IMT College of Engineering, Greater Noida, we are pleased to have our guest of speaker to join us today. Respected Chief Guest, Dr. Leeladhar Nagdeve, respected Director, Sir SS Tyagi, HOD Mechanical Engineering Department, Dr. Ganesh Sir, and professors and our dear participants. We believe this is an excellent opportunity to learn from you and inspired to think beyond. On behalf of everyone, I extend a warm welcome to you, sir. Our institution is a pioneer in research, entrepreneurship, startup, innovation, due to great leadership of our Managing Director, Dr. Mayank Agrawal, Director, sir, R&D cell members. We extend our heartfelt greeting to you, all of you.
Ojha, sir.
Yes, sir.
I think it is not live actually. It's not showing.
Yeah, it is going on, sir. It is live. We extend our sincere welcome to our dignitaries in the attendance. Your presence will enhance the workshop value. At this special moment, we would like to welcome all the attendees. We appreciate your willingness and enthusiasm to participate in this workshop, prototype design and development. Thank you for giving me the opportunity to host this session for the workshop. Dr. Leeladhar Nagdeve is currently working as a professor in Department of Mechanical Engineering at NIT Delhi. He has received his PhD from Department of Mechanical Engineering, IIT Kanpur. Before doing PhD, he obtained his MTech honors in the field of production engineering from MITS Gwalior and bachelor degree in the industrial and production engineering from the Government Jabalpur Engineering College, Jabalpur. His keen interests are nano-finishing of free-from sculpture surface, finishing of biomaterials, advanced machining process, magnetic and non-magnetic based nano-finishing process, hybrid machining, additive manufacturing, and material processing. He has various national and international projects, conferences. He has published more than 40 journal papers. Currently, he has also worked on the 2 MHRD AICT funded project costing around 28 lakhs, and he has more than 40 research publications. Hello.
Yes, please.
Yes, sir. So over to you, sir.
Yeah. Okay. Thank you. Thank you, sir, for your nice introduction. Okay. So first of all, I would like to give the thanks to Dr. Ganesh sir for giving this opportunity and for inviting this special talk entitled this particularly prototype process design and development prototyping. Okay, so just a second, I am moving further. Yeah, so welcome to the course on this prototype process design and development prototyping. I will be especially talking about the development of the particularly techniques, that is nano finishing techniques. In between, I will be also talking about the product development, how the ideas we have before developing the particular product for the particular application, there should be particular ideas. Okay, so that ideas came in our mind for developing the particular process. Okay, so that things we will see throughout the this particular session. So particularly about the development of the nano finishing techniques for free-form sculptured biomaterial surfaces. Okay, so myself Dr. Leeladhar Nagdeve, Assistant Professor in Department of Mechanical Engineering, NIT Delhi. So this is what I have organized this particular talk, keeping in mind the contents. So introduction, I will be talking about the freeform. What is the freeform surface? What is the sculptured surface? That would be applicable for the biomaterials. Then we'll be talking about the major applications. Why nano finishing techniques are essential? Why nano finishing techniques are required basically for the particular process, by keeping in mind the particular development of the products. If we are developing the products, if we are designing the particular product, but it's not enough to say that we have developed this particular process or we have developed this particular product. We have to think about the cost effectiveness of that particular products. So we will talk about that also. Then we will go through the classification of the nano finishing process. Then we'll be talking about the status of the nano finishing process. What is the status of the nano finishing process in India as well as outside India? Then important challenges that I will be addressing here, and research work that I have carried out during my research, during my this is the few glimpse of the research I will be highlighting here, and after that I will be coming up the conclusions. Okay, now the very important thing is, what is the freeform surface? What is the sculptured surfaces? So in my first slide, you can see these human implants. Okay, these are the human implant basically. So you can see this is the particular shoulder joint, this is the hip joint, this is a knee joint, and other parts are also there. So all these are the preformed surfaces in human body, and all these surfaces are all these materials are biomaterials. Biomaterials should be biocompatible so that this can be easily implanted in a human body. Okay, so I will be particularly talking about this particular knee joint. Okay, this is the knee joint. How we would be able to develop this kind of the surface, this kind of the geometry, this kind of the design for the wellness of the human being. Okay, so other freeform surfaces, you can see this is the dental implants, this is the heart valves. So all these are the types of the freeform surfaces. Apart from the human implants, you can see you will have this freeform surfaces like exhaust manifolds, airfoils, gears, glasses, helicopter bearing, all these turbine blades. All these things are considered as a sculptured surfaces, freeform surfaces. Now the thing is, how we would be able to develop this kind of the particular surfaces. After that, what are the various processes, what are the various techniques to finish that freeform surfaces? So challenge are that. So one challenge is how we would be able to develop that particular product. After that, how we would be able to finish that particular developed surface for the particular application. As I have already mentioned, the application area in the human body, in the medical field, particularly are these bioimplants. Okay, so if I will see about the particular definition of the freeform surface, means it cannot be defined by mathematical equations. Freeform surface can have any design, shape, and often no axis of rotation. And that's why we will having the machines, tooling, and abrasive medium is very essential for finishing of these surfaces. So whenever we are talking about these freeform surfaces, the question is how we would be able to finish these freeform surfaces. Okay, so after that, the potential application of these freeform surfaces, you can see the biomedical industries, aerospace industries, automobile industries, dye and mold manufacturing, semiconductor industries. So all these are the potential user of the freeform surfaces. Okay, particularly I will be talking about this particular femoral component, this particular knee joint. Okay, how we have developed, how we are developing the particular process for finishing this particular knee joints. Okay, so this is what about yeah, this video is not working, otherwise I would like to show here. Okay, no problem. So the inside of this video, you can see this particular implant, how this implant is implanted in human body in this particular leg. Because video is not working, sorry, no problem, but please try to understand and concentrate on this particular figure. We have, yeah, this is the real bone that is exposed in human body, and we want to replace by implanting these artificial knee joints. So we, so designing is very important about this particular joints, and finishing by developed process is another thing. So two things are there: process development and product development. Majorly, I would be talking about the process development basically. Okay, what are the various processes that can be developed, that can be used for finishing of this particular knee joint or femoral component? The same in the femoral head. This is the destroyed cartilage. This is the diseased hip joint basically, and we have implanted by implanting the artificial joints here. Okay. So these are the slide. This is the slides telling about the various implant manufacturing companies across the globe. So these are the US based companies: Germany, US, China, UK. All these companies are working on designing as well as finishing up the process, finishing up that particular product. Okay, in India, these are the listed companies. They are working for development of the product as well as finishing up that particular products. It can be said that they are very much worried about the process development. Once you have developed the product should be finished up to nano level for the application of as I have seen, I have shown in the first slide, the biocompatible material, that particular joint that should be finished up to nano level. If that surface would not be, I would like to go in this previous slide. If this surface would not be finished up to nano level, what will be happen? The problem will, if this is rough surface, then what will happen? So again, this will be, this basically, these are the two joints. Okay. So this joint will be continuously moving on this polyethylene cap. So this polyethylene cap, what will happen? This will be, wear and tear will be there. So ultimately, this implant will be fat. So that's why the finishing action would be higher on this particular reason. Okay. Okay. So this slide is fine. Now the requirement of the implants. So compatibility, mechanical properties, and manufacturing aspects. So whenever we are talking about the requirements of the implants, we have to think compatibility issues, mechanical properties, and manufacturing. So it is manufacturing means it's all about the process development, process design criteria, process design variables kind of the things. Okay. So in manufacturing, we have to talk about the particular fabrication methods, consistency and conformity to all requirements, quality of raw materials, superior techniques to obtain excellent surface finish or texture, compatibility of the material to get safe and efficient sterilization, and ultimately we have to talk about the cost of the products. Okay. No matter how much time you are wasting, ultimately we have to come up with the cost of the products. How much of that cost? Okay. So in particularly, whenever we are talk about the designing of the products, okay. So ultimately we have to come up with the cost effectiveness of that particular process. Okay. So cost effectiveness is very important criteria, very important variable we can say in the process development. Okay, these are all about the polymers. I am not going in deep of all this particular as I have mentioned here, the application of the polymers. These are the particular knee, hips, and shoulder joints are used for the polymers. Sometimes polymers are used for the biomaterials, biocompatible materials. Okay, so we have to talk about these are the list of the polymers, which are used for the application of the these are the particular things that just let me take this particular pen. Yeah, so I'm talking about this particular application for this particular polymers. Okay, so these are the list of the polymers that we have to go through for these applications. Okay, so not going to detail about this all these polymers. So once again, we have this material combination in total hip replacement prosthesis. Okay, so these are the femoral components. These are the socket components. Okay, and UHMWP, ultra high molecular weight polyethylene, is a very important biocompatible material which are used in the biomedical field. Okay. So these are the again list of the materials, principal applications of these materials. I am not going in details about this, just for the your information. This information has been taken from the material for medical devices ASME, ASM internationals. So these are the metal and alloys basically, which are used for these applications. Okay. So suppose 316L stainless steel is majorly used in the biomedical field. Okay, just for the application such we can say the fracture fixation stand and surgical instruments. Okay, all these are the metal and alloys which are used for the biomedical application. And about the ceramics and glasses. Okay, so these are again I have mentioned this particular principal applications for these materials. Okay, so these are the example of the medical and dental materials and their applications. So these are the materials like polymers, okay, which are used for these principal applications. So I am not going detail, just for your information I have mentioned this particular table. Example for medical and dental materials and their applications. Okay, so these are the composite materials which are used for the dental restoration and dental restorations. This is basically the dental cements. This particular composite material is used in the biomedical field.
So, sir, I want to ask here that all these material selection based on that parameters like compatibility, properties, mechanical properties, manufacturing, and cost.
Sorry?
Actually, I want to know that selection of all these materials based on same requirement means how we have to select these materials means compatibility, properties, manufacturing, and cost. Okay.
Yeah. So very nice question. Basically, biocompatible material basically depends on the particular requirement. Suppose I'm talking about the knee joint particularly.
Yeah.
So knee joint, so it will be depend on the particular strength of that particular material. Suppose I'm talking about this particularly knee joint. Okay, so this joint should be load carrying capacity.
Yeah.
So that's why we are using the stainless steel, biocompatible material, titanium alloy. Okay, so these are the load carrying capacities. It depends. Okay, suppose I'm using I need for the spinal joints. So based on that we have to, so there are the setup particular joints, set up the joints that can be used for the particular application. So yeah, it will be depend on the how much the that joint is load is carrying. Okay, so and the second thing is that should be a biocompatible material.
Biocompatible. Yeah.
So biocompatibility is very important basically in this case. Okay. Yeah, moving to further now why we are talking about the nano-finishing process. So this process is nano-finishing techniques are very important, and this can be as a process. These are considered as advanced processes. People can say these are the developed processes for particular application, for particular developed products. Suppose I have we can say the advanced material. Someone has developed the advanced material with advanced design, with advanced shape and size. So we can develop the process for that. And that is called as the advanced finishing processes. And why that nano finishing are required? So as I have mentioned here, why this nano finishing are required? So better surface finishing of the component is necessary to enhance the wear resistance, fatigue resistance, corrosion resistance, and friction characteristics and aesthetic appearance. So all these are the things that we have to say, yes, these are the things that's why we are needing the nano finishing processes. I will show in the upcoming slides what are these. So different types of the nano finishing processes and advanced finishing processes we will have. Based on the advanced abrasive finishing processes, we will have this abrasive flow finishing and chemomechanical polishing. Based on the magnetic field assisted advanced finishing processes, in this category we will have MF, magnetic abrasive finishing, magnetic float polishing, MFP, magneto-rheological finishing, MRF. And based on the rheological fluid based processes, so we will have the MRFF process. These are the very new terminology for the those who are in undergraduate or post, yeah, we can say those who are working in the those who are an undergraduate level. So this name would be we can say this name would be new for them. But those who are working in the particular research area like nano finishing, so they are very much familiar about these words. So this is the particular process which is developed for the difficult to finish materials. Okay, so I will be discussing about what is this process and how this process is working for the particular material which is difficult to finish basically. Okay, so again, this is the R-MRAFF process, rotational magneto-rheological abrasive flow finishing process. Yeah, now this is the very important figure where you can concentrate. So this is the abrasive flow finishing process and this is the MRF process, magneto-rheological finishing process. So we have combined both this process to take the advantage of individually, why we are hybridizing the process basically. So we want to take the advantage of both the process. So this process is not deterministic basically, and this process is deterministic. Deterministic and not deterministic means in this process we cannot control the temperature, but here we can control the temperature, and we have combined both this process and we have come up with this new process, R-MRAFF process. This is advanced finishing processes. Rotational magneto-rheological finishing. The detailed construction of this particular process I will be discussing in next slides. Yeah, the beauty of this process, you can see this is the fluid. This is the fluid. This is the smart fluid. Just take. Yeah, this is the smart MR fluid, magneto-rheological fluid. So anybody can make this kind of the fluid. They should have the abrasive mediums, iron particles, grease, and paraffin oil. Okay, and when this fluid, we have to stir it properly for mixing all the particles. And when this fluid comes in contact of the magnetic field, this is our magnet. Okay, this is our magnet. Okay, so yeah, this is the N pole, this is the S pole. So when this fluid comes in contact, this magnetic field, the brush-like structures are formed. You can see here the beauty of this smart fluid. Okay, and when we have when we remove this magnetic field, this brush will be come into in this liquid form. Okay, so this is the beauty. This beauty we have we can use in our process. Okay, for finishing up the any complicated shape. So this is the part of the development of the process. We can say yes, we have used the smart fluid for finishing of the difficult to finish materials. Yeah, this is the mechanism how this process is actually what is the mechanism behind the process. So first of all, that we can see, you can see here the construction of this particular setup. Okay, so we will have, this is the bottom hydraulic cylinder, this one, yes, top hydraulic cylinder, sorry, and the same we will have the bottom hydraulic cylinder here. Okay, so top and bottom hydraulic cylinder. Then we will have the top media cylinder here, where we have to keep our media, that particular fluid, as we have seen in previous slide. Here we will have the bottom media cylinder. So top media cylinder and bottom media cylinder. And in between this top and bottom media cylinder, we will have this workpiece fixture. Okay, this one. So hexaggregated view you can see here. So what is happening in this workpiece fixture basically? You can see here. So here I hope just place the magnets. Okay, here permanent magnets. Here this is the cylinder. This is the cylinder, and this is the cylinder. And here I will have my workpiece. This one, this blue color is my cylinder, my workpiece. Okay, this is the workpiece, and this is the abrasive mediums and CIP particles. So CIP particles which are ferromagnetic in nature, and iron particle which are non-magnetic in nature. And here we will have the paraffin oil which will be working as a carrier medium, and grease will be working as additives. So all these things are making this fluid, MR fluid. Okay, and the property of this magnet MR fluid we have seen in previous slide. When this fluid comes in contact with the magnetic field, the fluid is making the multiple flexible brushes, and those brushes are used for polishing of that particular you can say the job or specimen or any products. Okay, so how the material is removed from the workpiece? Since our media, this MR fluid, this particular medium is reciprocating with the help of this top hydraulic cylinder and bottom hydraulic cylinder. The media is reciprocating up and down, and at the same time, this fluid, this fluid is rotating with the help of rotating fixtures. Okay, I would like to show you the photographic view where you can clearly understand what is happening in this process basically. Okay, so this is the joint where we have want to get the nano-finishing surface with the developed process and developed prototype of that particular joints. Okay, so in upcoming slides I will show how we have developed this particular replica as a workpiece fixture for finishing this complicated shape. Okay, so here the mechanism of the process, how the process is working basically to finish up the complicated shape. Okay, so reciprocating motion is there, and fluid is rotating inside this particular fixture. So this is my abrasive particle. This is the two forces will be acting there basically. The normal force will be acting into the workpiece, and at the same time abrasive will be rubbing on that particular workpiece, and we have the axial motion of this particular fluid with the help of this hydraulic cylinder. So what is happening basically? So this abrasive is once indent and removed from the workpiece with the help of this hydraulic cylinder. So this is the basic mechanism of the process, this developed process. Once the abrasive is indenting to the workpiece, okay, with the help of the normal force, okay, indentation force, and material is removing from the material with the help of hydraulic action of the cylinders. Yeah, so this is all about the finishing process, international status. Okay, so I think the Japan, China, Roessler and Otek, okay, so all they are working on these particular processes. I'm not going to detail, but I have mentioned the weaknesses of the process. What are the weaknesses of all these processes? The conventional finishing processes. So they are non-uniform surface finish with high standard deviation of the surface finish, wear abrasion, wear behavior has been investigated, non-uniform surface finish, time consuming. So all these are the weaknesses of the process. Conventional processes, people are working on that. So this is the process that people are working for finishing of this particular joint. So here people have used the conventional belt for finishing of this particular joint. People are mounting a number of the workpieces in a single single workstation, and they are dipping in the particular medium, and abrasive kind of the actions will be there, and with the help of that they are finishing. But still these techniques are not viable, they're not feasible. Why? Because there will be the micro cracks, there will be the non-uniformity in the surface finish. Okay, so that's why these are the not we can say these are the not adaptable, basically not completely. We still this process people are using, and they are implanting human body. But what is happening basically at the time being, as the time goes, so after a particular time period, that implant becomes failure. Okay, so that's why we have to talk about the standard deviation about the surface roughness. Surface roughness should not be vary along to the surface. Basically, that should be uniform. Okay, this is about the international status. So IIT Kanpur, IIT Kharagpur, IIT Guwahati, IIT Bombay. Okay, so they are working on this particular process. They are developing the process by changing the design of the workpiece fixture, and they are changing the design of their own setup, and they are coming up the new processes and called the process development, basically. So this is the part of the process development, how we are developing the processes. So just people are changing the tooling, they are changing the here we are using the smart fluid, that is MR fluid. So people are also going through the characterization of that MR fluid. So it depends on how much strength of that particular MR fluid is there. So they are going through the various tests, various characterization, and they are using the efficient and high strength of that MR fluid for finishing of that particular component. Yeah. So this is the process about, this was the process that people are working. So this setup is developed in the IIT Kanpur. I will be discussing about, and I have already talked in the mechanism and schematic view of this particular setup. So how it will be working, how we have developed the prototype, how we have developed the fixturing of this particular knee joint, I will be telling you in the next slides. Yeah, this is all about the conclusion of the literature, why we have to go for the literature survey. Okay, so ultimately what we are looking for, this is not our part of the discussion today, that's why I'm leaving this one. So we are talking about the large contact area, more uniform surface finish, higher finishing rate, better surface finish, flexible tool, and critical analysis of the morphology of the surface. So all these things we are talking about the process. Okay, how we are developing the process basically, and how we will come up all these things as we are looking. So now see, these are the research gap. So extended replica of the workpiece with the proper holding equipments, large contact area, reducing finishing time, uniform surface finish, online monitoring of the process parameters, use of rotating electromagnetic poles, comprehensive modeling of comprehensive modeling by coupling all the physical phenomena, extended magnetic replica of the free-form surfaces, and 3D CFD simulation. So this is the extended magnetic replica of the free-form surface. So this is the part of the designing of the prototype. So this is the again a 2D CFD simulation. Now see, this is the very important slide where we have to talk about the designing and development of the replica. Means negative replica means this is the we will have this particular solid model of the knee joints. I mean, basically we have gone through the reverse engineering. Okay, suppose I have this joint, I want to finish this particular knee joint, but I don't have the proper holding arrangement, proper fixing arrangement for this knee joint. So we have gone through the reverse engineering. We have scanned this particular model, and we ultimately we have fetched all the datas, and we have gone for the 5-axis CNC 3-axis CNC milling machine, and we have come up this negative replica of the joints. Okay, so this is the developed fixture for this particular knee joint. Here we can see we are talking about the developed product, and we are also talking about the process modification also. So in process modification, I have already talked in previous slides, where we are changing the magnetic fluids strength as per our requirements. Okay, and we are changing the magnets, we are changing the setup shape and size as per our designs. Okay, so here we are talking about the particularly this knee joint. So with the help of the reverse engineering, we have come up with this particular prototype, particular design, and this is the schematic view. So how this developed prototype would be, this particular design would be helpful for finishing up the knee joints. So we have maintained this particular gap. Okay, here this will be my magnets. Okay, just a second.
Means, sir, excuse me, sir.
Yeah, please.
Yeah, means this negative replica plays a very important role when we have to go to develop the surfaces for particular product.
Right.
Yeah.
So yeah, just we have developed this particular fixture for finishing of this particular knee joint.
Okay.
So anybody want to finish any complicated shape, so what they have to do, they have to go for the fixture arrangement, fixture design of that particular. So this can be said that the limitations of this particular process basically, but no problem. Once we have developed the product, this can be go for the mass production. Okay, so this is the schematic view, how the material, how the fluid is flowing. Okay, we have maintained this particular gap basically. Okay, so this joint will go inside here. Okay, and we are maintaining the gap, this particular 6.5 mm gap we have maintained, and within this gap our media, our MR fluid will be flowing, okay, up and down and reciprocating, as we have seen in the earlier slides. Okay, so this is about our fixture as we have discussed in our previous slide. This will be the top media connector, bottom media connector, and here we have fabricated finally this one. Okay, so we have fabricated initially with acrylic material just to see the adaptability, and we can say how it is working basically. So initially we have developed with the help of the acrylic materials. So by using this particular material here, we want to see whether our this particular joint, this particular this specimen is properly fixing or not inside this particular fixture. So this is all about the development of that particular fixture. So this fixture would be applicable for uniform distribution of MR polishing fluid, uniform fluid flow, and gap between fixture and workpiece we have maintained this 6.5 mm, and it will cover the large contact area and reduce the finishing time. So once we are talking about the development of the product, development of the process, so we have to talk about the what should say, ultimately we are talking about reducing the time, and once we have reduced the time, definitely it will give the advantage for the cost effectiveness. Means we can say yes, we have reduced the cost of final cost of the products. Yeah, so this is another joint that we have gone the reverse engineering, and we have developed this model, and with the help of this we have come up with this fixture, okay, and ultimately we have fabricated this fixture for holding this knee joint, and this fixture would be helpful for fixing this particular knee joint, okay, and with the help of the process that we are talking about, the rotational magnetorheological finishing technique, with the help of that we can finish this product up to nano level. So this is the experimental setup as I have already shown to you. Once again, this is the photographic view of the setup, where you can see this is the top media cylinder, bottom media cylinder, okay. Sorry, this is the bottom hydraulic cylinder. Basically this one, this white color is bottom hydraulic cylinder, this white color is top hydraulic cylinder, this is the top media cylinder, bottom media cylinder, and in between we will have the fixture. So here I am keeping my magnetic fixture, and inside that I am placing my joint that we have developed in previous slides. So this is all about the setup. So see, this was the one setup, one design workpiece fixture, and second workpiece fixture we have developed here. Now you can see this is the shape and size of the that particular you can say this workpiece or specimen, okay. So with the help of reverse engineering we have developed this kind of the fixture for the holding of this particular joints, okay. Then okay, now we have to go for the surface roughness check. How we are measuring the surface roughness over to the joint, okay. So we have to go for a CNC machine for marking the particular point over to the surface. So once we have marked this particular point, we can check the surface finish before and after finishing, okay. So these are the metrology kind of the things that we have gone through our research work, okay. So these are the parameters that we have to maintain during the measurement, and this is the simulation kind of the things. We have to check how much magnetic field is generating over to the surface, whether the developed process or developed prototype, as we can say we have developed here workpiece fixture, and we are talking about the developed process. So whether this process are properly working or not, we have to go for the simulation. We have to check how much magnetic field is generating over to the surface. It is very important, okay. So we have to go for the simulation kind of the things, okay. So once we have checked the simulation, after that we have to experimentally calculate how much magnetic field is generating over to the surface. So it is experimental and simulation kind of the things about the process. So this is the this is the before and after finishing of that particular product. I mean, how much surface roughness is coming over to the surface. So we have to go for the atomic force microscopy, optical microscopy, to see the texture of that surface, okay. So this is the before and after finishing. So you can clearly see their scratching marks, indentation marks are there, that shows the finishing action is happening over to the surface. This is the rheological study of the newly developed media. So this is all about the, as I have already told, whenever we are talking about the process development, we have to go for the other connected things, other related things, like we are talking about the MR fluid. So we have to go for the rheological test of that MR fluid, okay. So these are the abrasive particles, okay, and these are the CIP particles. So we have to go for the same scanning electron microscopy, where we can see the structure, shape of the abrasive media, abrasive particles and iron particles, okay. So we have mixed all this and we have made the MR fluid. So these are all about the same analysis of the fluid, okay. And these are the finishing experiment results again. So this is the 2D results and these are the 3D results, where you can clearly see the abrasive actions, okay, scratches marks over to the surface. It shows the finishing action is taking place. Yeah, this is again before and after finishing. Okay, so in this particular case, we have removed, we have achieved 78 nanometer from 172 nanometers. Here we have achieved 89 nanometer from the 178 nanometer. So it depends on the that particular developed fixture and process and MR fluid also. Okay, so this can be vary depending on the our developed process. Okay, so this is again the 2D and 3D view of the surface. Over to the surface. It means we are saying that before finishing, the surface roughness was 230 nanometers, and after the finishing, we are getting the 75 nanometers. Okay, so you can see the novelty of the developed process and developed fixture here. So total finishing time is 64 was there in previous research. I mean, people have used the process for finishing the same joint by their own developed fixture or by their developed one process. Okay, and here we have developed the process with the help of this developed fixture, and we are reducing this time from 64 to 2 hours. So we have we are reducing, you can see, from 64 to 2.21 hours. Okay, so this is the biggest achievement of this research work. Okay, this is all about the conclusions. Just a second. Yeah, conclusions is saying the developed negative replica. Okay, negative replica means I am saying about that particular fixture, whatever we have seen the reverse engineering. Okay, so this replica of the knee joint as a fixture is recommended for differential finishing, but I am not talking about your differential finishing, but yes, this would be applicable for nano finishing. This R-MRAFF process, rotational magneto-rheological abrasive flow finishing process, is recommended for finishing of freeform surface up to nano level of the surface roughness with the special design of the tooling of the workpiece. Okay, if I am coming with a special design of the tooling of the workpiece, then yes, this process can be recommended for finishing of the freeform surface. Freeform surface means any complicated set. Okay, as I have already told in my first slide, this freeform surface cannot be defined by any mathematical equation. So it is very challenging how we would be able to develop the fixture for a particular process. So here we have achieved 26 nanometer. This is the you can say 26 nanometer, and the range of the surface roughness is 26 to 62 nanometer over to the surface. So this is the achievement by developing of the fixture. And nano finishing of the freeform surface with special design of the tooling of the workpiece. This process is recommended, and we have reduced this 64 hours into to 2.21 hours by developing the replica of that particular fixture. Okay, so diameter of the magnetic fixture can be optimized so that maximum and almost uniform magnetic field can be achieved over to the surface of a femoral component. It will reduce the finishing time and surface roughness of the femoral implant. So overall, we can say whenever we have to talk about the prototype development of the prototype, whether it can be shape and size of the product, whether it can be development of the process. So two things we are doing basically in this particular research work. We have developed the replica by going through the reverse engineering. Another thing is we have developed the process for finishing up that complicated shape. That is, we can also say that the materials which are difficult to finish, so we have to go for the advanced finishing processes. So those who are interested in the recent topic, they can think about that, and they can literature also, and they can choose according to their requirement or according to their chosen areas. So thank you very much. Here I am completing my talk. If anybody have any questions, they can talk, they can ask here. Yeah, Dr. Ganesh.
Yeah, thank you, Professor Nagdevi. You have in detail described the advanced manufacturing processes and how to develop the prototype setups for research work, or how we have to reduce the process time, machining time. You have discussed various machining processes. What are the advanced machining processes are there? How we have to do that processes for machining and surface finishing, and where you have described very well, and how we have to set up particular for that particular applications, how we have to develop the setup, and also very important, how we have to reduce the time, and how we have to use reverse engineering for producing the replica. So thank you very much. That's these are the things student will have definitely have to learn these things, how we have to, they have to set up the prototype, how they have to develop the prototype for prototyping, how they have to set up the models for experimental work or any developing the products. This will definitely benefit them. Thank you, sir.
Thank you. Thank you very much for giving me opportunity.
Thank you, Dr. Leeladhar, for accepting our invitation and for enlightening talk. And this is a very useful talk. From your research, it seems that you have blended all the engineering which is required, and you have implemented it for biomedical applications. And this is how like the current engineers has to contribute for the service of the nation, and then they have to apply the knowledge so that the real life problems can be solved. So once again, thank you for such a nice session, and thank you for accepting our invitation for this guest lecture. Thank you once again.
Thank you. Thank you.
Thank you. Thank you, Dr. Ganesh, and thank you, Sunil sir.
Okay. Thank you.